Well, today we're going to discuss the next part of kinematics that you recall we have already discussed a few fundamentals. Let me just give a brief recap of what we have already done. The definitions the parameters that we are going to use extensively throughout physics are number one, position, number two, displacement, distance, velocity, speed, and acceleration. So I try to actually define by giving a practical definition. As I said the other day, the whole concept of giving a practical definition, but not the bookish definition, is that you understand the concepts that are embedded in the statement that is given by me. So that is number one. Number two, I spoke about two very important aspects yesterday, the other day. One, the concept of instantaneous value and average value. The instantaneous value refers to at a point or at a time, and the average value always refers to over a given time interval. Now, this is a very important thing. And when do you get instantaneous value and when do you get average value? That also I made a mention of that, I think, in my previous lecture. Whenever you use derivatives, you will get instantaneous value. Whenever you use differences called finite differences, total displacement by total time, that is what we call as instantaneous, average velocity. Similarly, the change in velocity by change in time is your average acceleration. This is what I try to do. Now, we will be using these concepts in the course of our lecture, but I think the next automatic next step is 1D motion. In fact, we can talk of 1D motion, 3D, 2D motion, and 3D motion also here. Now, this 1D motion, what is that 1D motion and what is this 2D motion? We will discuss this very briefly. Number one, 1D motion is nothing but a straight line motion. Straight line motion means actually a particle or a body or an image or a shadow may be moving only along a straight line. Now remember, whenever I talk of along a straight line, I always mean this particular movement can have two possible directions. We may call it forward, backward, up or down, back and forth, etc. So this is in a way bidirectional, because straight line motion is wrong to say it has only one direction. It's a misconception. You have to remove all that if at all you have it. Now, the straight line motion is a bidirectional motion. When is that bidirectional? When is the straight? That we will discuss after this lecture. Now, straight line motion, this is a 1D motion. Next is 2D motion. 2D motion is in a plane. 2D motion is in a plane. So, this has got to be a curvilinear motion. Curvilinear motion. Incidentally, you may call this as linear motion also. So, curvilinear motion in a plane is called 2D motion, and curvilinear motion in 3D space is called 3D motion. This is how we define we do not discuss curvilinear motion for the time being. We confine all our attention to 1D motion till I say otherwise. Now, coming back to 1D motion. Now, this is very important because most of the time we come across these problems not only in kinematics, any subsequent topic you take in physics in the coming 2 years, you do come across this 1D motion at every stage, right? Now, what do you mean by this 1D motion? For example, I say some velocity is given as, in one case, say 3i, another way we call it as v1, v2 bar may be 2i plus j, something like another velocity may be 3i plus 4j plus 2k, something like that. Now, the purpose of giving all these three to you is very simple. Which one of them would you call 1D motion? I know that 90% of the people say this is 1D motion, this is 2D motion, and this is 3D motion. Now that is absolutely wrong. Why? Because 1D motion means straight line motion. A straight line motion can be in a plane I plus j. If this is I, this is j, I can draw this as I plus j. That is possible. That is possible here. In a similar way, you take a room from one bottommost corner of the room. If a particle is going to the topmost diagonally opposite corner, then that could be a straight line motion. So, but what is the velocity that you give there in terms of I, j, k all put together? Therefore, I, j, k is not going to determine the dimension. Then what determines the dimension as far as our 1D motion is concerned? Now we say that if a particle's velocity and acceleration both are in the same straight line, then we say that it is a 1D motion. What do you mean by the same straight line? I give you, suppose this is how the velocity is in a particular case. Now, in the same instant, supposing if acceleration is also in the same direction. So what will happen? The velocity, the magnitude of velocity may go on increasing, but its direction will not change. In the other case, if the velocity is like this, acceleration could be in the opposite direction. In which case, the magnitude of velocity may decrease in time, but the straight line motion is not affected. There is a possibility that if this acceleration persists for sufficient time, then there will be a stage when this particle's velocity becomes zero. I'll show you like this. And if it continues to act, the particle reverses its direction. So then it goes on increasing the magnitude of velocity. But mind you, although it has reversed its direction, remember the straight line motion is intact in all these three cases. Now, if there is no acceleration at all, then the body is bound to move with the so-called uniform velocity, where a is equal to 0. That means if the uniform velocity is bound to be a 1D motion. So remember, I, j, k is not going to determine whether the motion is 1D or 2D. But what determines is if the angle, I'm now summarizing this, if the angle between the velocity and angle between velocity and acceleration must be either 0 or pi or 180. then the motion is said to be one-dimensional motion or simply 1D motion. This is what I want you to be very, very careful about. You understand this? So in this case of 1D motion, where, as I already told you, where we do talk about various aspects, not one or two. In 1D motion, there are plenty of cases that we are going to look at. Now, in 1D motion, now I can give any case which pertains to analytical expressions. Say, for example, x is the one particular direction. X is given as say 3t square plus 5t plus 6. Supposing if it is given like this. Now, if I want to get velocity here, I will directly get dx by dt as how to get the derivative I already told you, and you are expected to be thorough with these simple derivatives and simple integrations. These things were already explained to you before. Therefore, if I write this, it becomes 6t plus 5. So I'll directly get, I still call it as 1D motion only. The 1D, just because t is cube or square or to the power 4 or to the power anything, it doesn't have got anything to do with the 1D motion or 2D motion. Because I have given only this x direction, and in that direction only the particle is behaving like this. In fact, x versus t is non-linear, but path is linear. Now that is important for us. Okay, that's how we get the velocity. If I want to, this is what we call as velocity. Suppose if I want to get the acceleration. How do you get the acceleration? As I told you, it is dv by dt. So v is this one 60 plus 5, and 60 if you differentiate you will get as 6. And remember, a is not a function of time. In other words, this is a case where a is a constant or uniform. Therefore, you can call it as uniform accelerated motion. It's not uniform motion, uniform accelerated motion. And if x is given by this expression, for example, if I take x as a linear function of time, let us say 60 plus 1. What is velocity? Now you can directly tell me dx by dt is equal to 6. Now velocity is not a function of time. So this is a uniform velocity. Uniform velocity. That means this is 1D motion without any doubt, and then it is moving unidirectionally. No bidirection here. The same direction it keeps on going, that is uniform. If I take a as dv by dt, then the acceleration becomes 0. So whenever the acceleration becomes 0 in 1D motion, remember I am talking of 1D motion. So this is what we call as uniform motion. The previous case is what we call as uniform accelerated motion, right? Now, one thing which you should definitely understand here as far as acceleration is concerned, I slightly deviate from 1D motion by looking at the general expression for acceleration, which is nothing but dv bar by dt. Now this v bar, that velocity consists of magnitude and direction. Therefore, acceleration can be due to 1. Change in magnitude only. That means the magnitude of velocity alone changes. then acceleration results. If acceleration is due to change in direction only, then also we say that means magnitude of velocity is constant, but the direction keeps on changing. Then also we say acceleration is present. Now finally, change in both. Now this is a very, very important concept of acceleration. As I said, there's nothing to do with the 1D motion, but you should understand why I am talking about this at this stage. Let us look at one by one. Change in magnitude only means what? The direction will not change. So if it is like this shaft length is the magnitude of velocity. Arrow obviously indicates the direction. Therefore, the magnitude is decreasing with the time. So velocity is in this direction and acceleration is in this direction. So change in magnitude only. Now, whenever it changes, the magnitude changes, it is because of acceleration, that is along the straight line, either in the same direction or in the opposite direction. This is the opposite direction. If you want to get in the same direction, this is velocity and this is acceleration. The magnitude goes on increasing, increasing, increasing. In this case, the angle between the velocity and the acceleration is 0. In this case, the angle between velocity and acceleration is 180 degrees, or we call it as pi. You remember, we already defined this before, that whenever the angle between acceleration and velocity is 0 or 180, then we call such a motion as 1D motion. And incidentally, very important, that acceleration in 1D motion is called tangential acceleration. Although we are supposed to put a subscript T here, we avoid because we know that it is 1D motion when you talk about that, and we automatically understand that that is bound to be tangential. In fact, I can tell you, whatever you people have learnt, those so-called equations of motion in kinematics, remember, V is equal to U plus AT, S is UT plus half AT square, V square is equal to U square plus 2AS, etc. There are so many such equations that you have used to work out several numerical problems before, if you recall. All that acceleration that you were using is nothing but your tangential acceleration. But we don't put the subscript T. So how do you define tangential acceleration? It is nothing but rate of change of magnitude of velocity. It is rate of change of magnitude of velocity. It is called tangential because it is either along the straight line or opposite to the straight line motion. Therefore, in both the cases, it is tangential. That's why it is called tangential acceleration. And in 1D motion, we are going to use only A. A there means tangential acceleration only, unless otherwise I state something else there. Now, coming briefly to the second case, what does the second case tell you? The rate of the acceleration results due to change in direction only. That means magnitude of the velocity remains the same. Look at this. The length of the shaft is everywhere same, but the acceleration there is always called centripetal acceleration, or this is also called radial acceleration. The details of this we can discuss only in 2D motion or circular motion, not at this stage. But you should understand that this acceleration is written as either A suffix R, is always directed towards the center of that so-called curvilinear motion, right? So the angle between AR and your velocity is always 90 degrees. You understand now? First case is the angle between velocity and acceleration is either 0 or pi. What is the meaning of that? The motion is bound to be a straight line motion or a one-day motion. If the angle between the two is 90 degrees, then we call it as a curvilinear motion with no change in what? The velocity, and this is called uniform circular motion. I am not going to discuss anything pertaining to this. I am giving you a reference of this only because I had to distinguish the two types of accelerations. I hope this point is clear. First case, acceleration is tangential. Second case, acceleration is normal or perpendicular. Now go to the third scenario. What does the third scenario indicate? For example, this is how it is curvilinear. So the radial acceleration is bound to be present, but possible that the velocity may be increasing. And at any point, if I take this is AR, and since the speed or the magnitude of velocity is increasing, there is a tangential acceleration also along the velocity because the magnitude is increasing. If the magnitude decreases, the acceleration is bound to be opposite to the direction of motion. So, if I look at the resultant acceleration, which we call as acceleration vector, that is making an angle which is acute with the velocity. So the angle between acceleration and velocity is less than 90 degrees, 30 degrees, 40 degrees, 50 degrees, but not 0, not 90. In such a case, this is non-uniform circular motion. Non-uniform circular motion. That's how you are going to get. In this particular case, where do you come across certain people to show off? People who are on the bike, when they get the new bikes, they want to show off to the pedestrians or the people who are around them. While taking a turn, they go on increasing the accelerator so that it gives more sound or whatever, kind of a play. And then ultimately the vehicle is going to skid, and then the rest is you know very well what's going to happen. So that is such a kind of a thing which is totally unwarranted, of course. Now the second case is, in this, while taking a turn, the judicious way is to decrease your magnitude of velocity and then take a turn. And now look at this. If I take here, as usual, AR is perpendicular, but AT is opposite to the direction of motion. What is the total acceleration? This is total acceleration. What is the angle between these two? So obtuse angle. So when you have an obtuse angle, what does it convey? Motion is curvilinear, number one, that is two-dimensional motion. Then two, the magnitude of velocity goes on decreasing. Now when it is acute angle between the two, what do you interpret? How do you interpret it? That it is curvilinear, it is 2D motion, but the magnitude of velocity goes on increasing. These cases we will not discuss at this stage. I want to give a complete picture of what do you mean by this acceleration before we discuss the actual 1D motion. Okay?